People who like to replicate data by copy, they have 50, then they copy paste, copy paste, copy paste, copy paste, copy paste. When you do that, you're going to have VIF, very high VIFs. Now your variance inflation factor should not be greater than 4.0 for any of the indicators. It should not be greater than 4.0. Now, if you've copied and pasted to increase your sample size, your data is only going to measure the same thing. So the variance inflation factor is going to be high. So it's just an advice for anyone who wants to do so. This is how people get to know that your data is not genuine. Yeah?
Can you please explain what does VIF explains?
This is collinearity. It is simply the relationship between your data points, you know?
So
they are collinear. Meaning they are measuring
collinear.
the same thing. Yeah, they are measuring the same thing. So if you repeat the same set of data in 1,000 places, it means they are the same. That's just the concept of it.
Does it mean that we're having similar responses?
No, it's not the same. Similar responses cannot cut across all your data sets, you know?
Hello?
Yeah. So please just have in mind that the variance inflation factor should not be greater than 4.0. That's the condition. We don't have a lot of time, so I don't want us to waste. Just have the condition in mind. Your VIF should not be greater than 4.0. Very important.
It should be from 1 to 4?
Should not be greater than 4.0. It can be from 1 to 4, yeah.
All right, thank you.
Yeah. So now we need to move because we have a lot to cover. Now here we've exported the output of the measurement model. Somebody asked a question if there's a way we can use t-statistics, and we'll get there, don't worry. Now, this is very important, a very, very important aspect. Now, there are instances where when you run your analysis, because of the poor quality of your data, you're not going to have convergent and divergent validity. You're going to be having very bad values. And the only reliable way not to face that problem, you can be on that problem for a whole semester, you won't solve it if you're trying to manipulate or transform or do this or do that. The only reliable thing to do is make sure, especially when you're collecting primary data, pay attention to your instrumentation. Pre-test the questionnaire, especially on people who are knowledgeable in that field. Or make sure that you're using reliable skills. And after doing that, take a sample, maybe 20 or 30, test the data, pilot testing, very important, before you collect the final data. If you just design a questionnaire, you jump to the field and you collect the data, well, you face a lot of challenges. And if you're concerned with reliable results, it could be very detrimental to your outcome. Now, apart from instrumentation, as I mean, you can also examine the factor loadings, the pairwise correlation. You don't want your indicators to be too highly correlated, and then examine the outer loadings and the cross loadings. You can read a little bit on that. So now, this was supposed to be before the break, but we couldn't finish it. Now, we have evaluated our measurements model. The next thing is our structural model. Now, please, let's go back to our path diagram. Now, if you're there, just click on one, and you can highlight Control A everything, right click. You can click on one, Control A everything, the way you select everything, then you right click. When you right click, you'll see an open or a popped up window, little window. Select, delete, invert measurement, hide indicators. Now, so far, we have been dealing with the measurements model. Now, I don't want to deal with these indicators again. So now my focus now is on the structural model. And as I mentioned yesterday, the structural model is simply the relationship between the latent construct. So to hide those indicators, click on any of the constructs, Command A or Control A on PC, right click or whatever works for you, Command A. To open this, then go to hide indicators or show indicators. If you show, they come back. If I click again and I hide, they come back. It's like this. Now, the structural model validation is simply an assessment of the relationship between this construct. So the question is, how do you assess that? The first thing is the path coefficient. Now, the path coefficient simply means these values here. That was why I removed it. This value, like between competency and customer loyalty. This is the path coefficient. Now, this is simply telling me that there's a negative relationship between them. And how you interpret this is that a 1 unit increment in competency level, because of the negative sign, will lead to a 0.03 decrease in customer loyalty level based on the sign. But this is simply telling us there's a relationship. The question is this statistically significant? Because remember, we are testing hypothesis and we need to validate the hypothesis. But before we get there, this is how you interpret this. So likability and this is telling us there is something. There is a relationship. But is it statistically significant? So that is what this is talking about. So if I should go back here, the next thing is the explanatory power. The explanatory power. Now let me go back. If I should go back here, coming. I don't want us to do this one now. I want us to, we'll come back there, don't worry. We need to run another analysis together. Inner model. Okay, we'll come back there, don't worry. We'll run it. Let me explain this before we run the analysis. Okay, I was explaining this earlier. F square. Okay, now I want us to know this because when we run the analysis, we are going to get these values soon. The coefficient of determination, known as R square, is simply the amount of variation in the dependent variable that has been explained by the IVs or the independent variables. In this case, in structural equation modeling, we say the coefficient of determination is the amount of variation in the endogenous latent construct that has been explained by the exogenous construct. Now, the rule of thumb is that any R square value between 0.1 to 0.12 is considered to be low. 0.13 to 0.25 is considered to be average or fair, and anything above 25% is considered to be high. Now, the F square is similar to adjusted R square in our regression analysis. It's actually a construct meant for structural equation modeling. It is synonymous to this. And it measures the same concept. It is only adjusted. So similar to your, so it's also measuring the variation in the endogenous construct that is reasonably measured by the exogenous one. Now let's go back and run this analysis so that we validate this model. So you come back here. Now you go back to calculate. Now, the first time while running the analysis, we chose PLSM algorithm. But this time around, we are not going to choose PLSM algorithm because we want to generate p-values and t-values so that we can see if our model is statistically significant. So we choose bootstrapping. Now, bootstrapping is a non-parametric procedure that involves resampling the data set randomly with replacement. It's a random process with replacement. So let me just, so the literature suggests that our subsamples should be between 1,000 to 5,000. That is the suggestion in the literature. I think I mentioned that somewhere. Come on. Yeah, here. It says Data should be resampled through random selection of 1,000 to 5,000 sampling procedure. So that is what the literature suggested. So you go back there. So you have to set this between 1,000 to 5,000, but I think the higher the better in my opinion, but make sure it is at least more than 1,000. So let's run it at 5,000. Please set this to 5,000. Set this value to 5,000 and let's perform our hypothesis testing. I'm assuming we are all there. If we are there, you click Start Calculation. You wait for it to finish the calculation. Boom. System is so cool to use. Automatically, the results are out. Now, do you notice that initially we weren't having this value here? Do we have a result now? Do we have this?
Yes, same.
Yes, we have.
Yeah. So this is the R-square value I was talking about initially. So the R-square value, what this 0.413 is telling us is that competency, likability, and quality criteria, they all together explain about 41.3% of the variation in customer loyalty. That is what it's saying. But for us to really see the statistical significance of this, please, on top of your screen, you can see construct, inner model, outer model, highlight path. Please drop down the arrow. You see, but we don't need all this. What we need is actually the inner models, because we are dealing with the inner model. Now, I want to see the path coefficient and P values. Yeah?
If you don't have this on top
You don't have
of
what?
how can we
Hello?
construct inner model, outer model?
Should be somewhere. But do you have this output?
Yes, please.
Yes, we have it. We have.
If you're using a Windows machine, I think the display may not be the same, but it should be somewhere.
Yeah, a display on the left-hand side of yeah.
Oh, left
It's on the
hand side.
left-hand
Okay.
side.
Yeah. If you're using a Windows machine, the display may not be the same. Please, have you figured it out?
Yeah.
Okay. So now just go to the inner model, click it. We want to, we like p-values. P-value less than 0.05 is statistically significant. We like to repeat that. We love statistical significance. So click path coefficient and p-values. Now, if I want to do the same thing for the outer model, I can bring back my indicators. So let's do what we did before. Click one of the construct, Command A. I'm coming. Command A is okay. I have to edit, please. I have to edit. So you click on edit, then you click one of them. Command A, it highlights. If I should bring back my Command A. Let me go back. Let me. I don't want to cancel. Okay, I'll bring it back. Then we'll rerun it. Let me. Okay, it's back now. Please bring back your indicators. I don't know why it's not coming. Normally, if you just click on right click, as I was doing here, I don't know why it's not coming. If I come here, Command A, oh. Command A. What we did before, please try and do it and just click on show indicators. This will show again.
I think when you right click, the cursor must be on the latent variables, so that
No, you can click
select.
an empty space. It works anywhere. I don't know what. Yeah, it can.
Hello.
Hello.
Hey, Kwame, what happened? Yeah, hello.
Yeah, not yet.
Please hold on for a moment. I think he he's gone left up, the yeah. meeting, so he'll come back.
But I hope you get what he's trying to say. Do you get it?
Yeah, I lost along the way, so I watched the video.
Where did you
Yeah,
get
yeah.
lost?
I went
clear,
out to
we
pick my ID
understand.
and I came back and I'm lost.
Oh,
I
so
probably
you
watched the
left. So
video.
that one is okay. You will catch up. Okay. So he wants you to unhide the outer model you hid when you selected
Yeah.
everything. Hello, Doc, are you back? When you selected everything and then you right-clicked and you hid the outer model, that's what he's
So,
asking you to undo it.
so all of the result becomes 0.00.
No. That is the p-values. The 0.00 you are seeing is the p-value, but then you realize one is 0.6 something. I think the
All are zeros.
all are not zeros. Are you talking about the outer or the inner? So he's asking
The
select this.
p-values are the zeros. They are the lowest value.
Yes, I'm talking the p-values, yeah.
Okay, the p-values are in brackets, and then the magnitude, which is the coefficient.
Okay, it's 0.672.
Yeah, the
One is
first variable
0.67.
is 0.6 in the bracket, which is not significant. So I think Doctor is back. Hello, Phil. Okay, so Doctor is not back. And hold on, let me quickly reach out to him.
I'm back.
Oh, okay,
Hello?
okay. I just saw the message.
I don't know, my
Okay.
connection just went off, so.
Oh, okay. So take over.
Where was I? I think I was here. Was I here? Yeah, I think we're here. Please, can you see my screen?
Yeah, we can
Yes.
see it.
Okay, so we're here. So I was trying to bring back the indicators. So now you can see for the outer model, you can also bring back the path values for the outer model by going here and you click on outer weight and p-value so that all the factor loadings are showing in addition to the p-values. Let me adjust this. You can see, just for it to be clear. Okay, like this. Yeah, like this. Just for it to be clear, like this. Now we have our path coefficient and we have the p-values. Now, even if you can't remember anything, just know that at 95% confidence level, your p-values should be less than 0.05.
All are zero.
At 95% confidence, if you're testing at 95% confidence level, your p-value should be less than what? 0.05.
0.05.
Yeah, very
Yeah,
important.
then
And your t-value should be greater than 1.96. Should be greater, and your t-value should be great. If we decide to let's change it from p-values to t-values and see. If you go back to the inner model or outer model, let's do like this. Okay, so I have t-values there. If I change to t-values as well, you can see that all my now I have the factor loadings and the t-values. Now I have the path coefficient and the t-values. So you can see my t-values all are greater than what? 1.96. So it means they are statistically significant. But usually the most quoted metric is the p-value. So we can just maintain the p-value for the outer and inner models. Yeah. So now let's interpret the outcome of our structural model. Our first hypothesis, we stated, if we had stated that there's a significant positive relationship between competency and customer loyalty, the outcome shows that what? Our result is not statistically significant, isn't it? Because the p-value in the bracket is greater than 0.05. So in that case, we fail to accept the hypothesis. And we conclude that what? there is no statistical basis to conclude that what competency level has significant impact on customer loyalty. That's what the data is saying. Now, likability, the p-value is what? 0.001. This is very significant, right? Very
Yes.
significant. Same thing with quality. Now, there is this problem of we have a data set, we have our hypothesis, and we are expecting that our results should be significant. Dr. Kwame.
Doctor, why are you calling me?
Because it's a problem in academia these days. Everyone is expecting a significant relationship, but I think from discussion with some academicians, like the problem is if you are expecting the result to be significant, then why are you doing the research? You already have a biased expectation in mind. And then we also need to consider the fact that demographic factors, cultural factors, and different factors can influence the outcome of our result. And the best practice that I've seen is to try and justify those conditions, those outcomes you're getting based on literature. That's the best. Instead of just trying to manipulate the data so that the data will confess to whatever you're saying. And there was this American professor who said that if you beat data enough, it will confess to whatever you want. So we should be very objective in our analysis and let the data speak for itself.
Hello?
Okay. Yeah.
Doc,
Hello.
please, can I ask a question here?
Please ask a question.
Yeah,
On the
thank
phone-
you. With
Wow.
the maybe your hypothesis, you stated positive significance,
Yeah.
and then the results you had a positive. You had a significant, but it's negative. Are you going to accept it or reject it?
Now you've stated that your result is what? Your hypothesis is positive. You have a positive
Positive.
relationship, right?
Significant, and you have a negative
Mhm.
significant. Are you going to accept the null hypothesis?
But you can't accept because that's not what you're testing.
Okay. Okay.
That's why when you're stating a hypothesis, you have to be very, like yesterday I was saying that when you're stating your hypothesis, the moment you add the word positive, negative, you've limited yourself to the outcome you're expecting.
Okay.
So it becomes a one-tail test, no longer a two-tail test.
Some professors do. If you don't state that way, they will tell
Yeah,
you it's wrong. You
I
need
understand
to
that.
be specific.
I understand. That is why, stating a hypothesis has to do with a rigorous perusal of literature, You have to consider literature very well to make sure that what your assertions are well grounded theoretically.
Okay.
Yeah, that's the only way to go about it. And then when you're choosing your construct or your data point, make sure that those variables actually measure those constructs you're hypothesizing about. So if you have a good measurement scale and you have good data, you should get the outcome you're expecting.
Okay. Thank you for your explanation.
Okay, so now we have our structural model sorted out. The result is significant, and if you want to look, you can also open the report. You can check it. Some people like a lot of diagrams. You can look at diagrams. You can look at all the other things. You can explore this on your own. It's easy. Just take a look at it. The path coefficient is here, so you have this result. Now, why is this obstructing my? Now, if I close here, let's look at our result. From the path model, we can already tell that competency to customer loyalty is not significant. We can see it here. The p-value is the same result from the path model. So you have this output, you just export it also because you're going to need it to explain your structural model. So you click on Excel, you export to wherever you want to save it. Because I've already named something like that, I can name it 2, customer loyalty 2. Then I can just save it.
Ludo,
Yeah.
is that part of
So
the
you-
screen is not showing? You are not sharing.
Really? Oh, sorry. So like, can you see my screen now?
Yeah.
Yes.
Yeah.
Yeah.
So
Yeah.
I'm here. So you, please just click on the Excel at the top, the way we did it for the measurement model. Click on it. Can you see my screen?
Yeah.
So export it, choose the folder you want to save it, and save. Export. Choose the folder, rename it. If you maintain the customer loyalty before and you're saving in the same folder, it's going to tell you to replace. So you can add 2 or something just to differentiate the names. Then you click on save. Then you save. So because I've already named my customer loyalty 2, it's asking me to replace. So if I replace, it's still going to, okay, it's already, it's opened already, so I can't save it again. But I'm sure we all got the process, right?
Yeah, we got it.
Thank you so much. So we've saved our measurement model. Please always remember to save. We've saved our structural model as well, because those are the outputs you're going to use to write your final report. Oh, there's something I didn't mention. I'm sorry. I'm so sorry. Please come back to your model. If you open your Excel sheet, you will notice that the model showing is not having all these parameters. Have you noticed that?
Yes, I was about to ask
Yes, I actually forgot, please.
because
So-
you can't find the
Yeah,
coefficients
thank
and
you,
those stuff.
thank you. It escaped my mind. So the Excel sheet will not give you that. So you have to save this image on its own. So all you have to do is that right-click on, right-click on any portion of the screen. If you right-click, it will show you select or export as image. I don't know if you've seen it.
Yeah, we
Have
can
you seen
see.
it, please? Yeah, so choose
Yes.
export as image. Then you can, if you want to keep it on clipboard, that means you have to go somewhere and paste it. If you want to save it as an external file, it will open a window for you to choose where you want to save it. So I want to save my own here. So I just save it. So in that case, you have this picture for yourself if you want to report it. That's how you save the
Again,
image.
I cannot save image.
Okay. Are you on this page?
Right.
Can you see my screen?
Yes.
Please, can you check your screen sharing again? Because we don't
It's
see
not-
the pop-ups.
But can you see my screen right now, please?
Yes. Yes.
Yes, we can see.
Okay, please right-click. Just right-click.
Right click.
Did you see something like
Done.
export image?
Yes. And then
Click,
clipboard.
click on it. If you click on what's it called? Clipboard. It means if you do this, if you choose clipboard, it means you want to paste it directly to maybe a Word document. But if you want to save it in a folder, you choose external file.
Okay.
Do you get it? So let's
Mm.
assume you want to save it in a folder where you saved your Excel sheet. So you choose external file. But if you copy it and paste it on clipboard, that means you're going to paste it manually yourself.
All right.
So choose
Yes,
external
done.
file, export, and you
Yes.
save it. Thank you very much. So as soon as you
Yes,
save it, it will show you that you have the image. So that's how you keep your path model analysis and you get to report them.
all right.
Yeah.
Thank you. Thank you.
You're welcome. So I think we are done with this. Our time is almost gone. We have something else to do, and let me see. We still have one final analysis for the day. I think let's quickly go through it. Now we've done hypothesis testing, we've done bootstrapping procedure. The next thing we want to do now is we want to assess the predictive power of our model. And I'm going to browse through this quickly because of time. Now, so we are looking at what we call the PLS predict procedure. Now, this is a way of validating your model. And the most commonly used metric is what we call the root mean square error. And another one is what we call the mean absolute error. In most cases, it is more desirable to use the RMSE. However,
No.
yes,
Please, are you sharing?
you're
the
not seeing my screen?
PLS?
No,
I can't
I'm
see
sharing
any other
my,
thing.
oh, sorry. How come it's not showing? I'm sharing my, I'm coming.
We can't
Can you,
see from the PPT.
can you see the PPT now?
No.
Cannot.
Okay, let me stop the sharing and share again, please. I don't know. Mm. Can you see the PPT now?
Yeah,
Yes.
Adam.
Okay, thank you. Thank you. Sorry for the break in transmission. Okay, so now we want to do one last thing for the day. I'm going to probably eat about 10 minutes of your time. So now we want to assess the predictive power of our model. And that was what we call the PLS predict procedure. Now, there are two main measures of this, what we call the root mean square error, RMSE value, and the MAE, the mean absolute error. Now, in most instances, it is suitable to use the RMSE value, but as we would see in our example, if the error terms are highly non-symmetric, that means when they are not normally distributed, then it is imperative for us to use the MAE values. We will see that very soon. Just put this in mind. Now, this is the procedure. This is the criteria for us too. If all the indicators in the PLSM analysis have lower RMSE values compared to the naive LM benchmark, the model has high predictive power. If majority of them does, then we have a medium. If minority, we have low. And if none, we have no predictive power. So let's quickly, just keep this in mind, we'll come back to it. We want to run this analysis. So what we'll do is that we go to our PLS. Please, when I launch the PLS, if you can't see it, let me know, please. Can you see my PLS screen?
Yes.
Okay. So now we
Zero
want to
point
run the PLS predict algorithm. So you just go to calculate, then you choose PLS predict. So you click. Now the number of votes should be 10. By default, yours may not be 10 because I've been using it. The number
Excuse
of
me?
votes.
PLS
Yes.
predict. Okay.
You go to calculate. Remember, we use PLS algorithm, bootstrapping. Now we are using PLS predict. So you click on it. You set the number of votes to be 10, number of repetitions to be 10, leave the seats to be fixed. That's all. Make sure this is 10, this is 10. You go to PLS setup, make sure it is under path analysis, not PCA, not factor. Are we there? After doing that,
Yes.
you run the analysis. Now, when you run the analysis, you're not going to see anything, unlike the previous one.
Sorry, when you go to PLS setup, what do you choose?
PLS predict. Did you get it?
Yes.
Let's do it again. Please follow through.
Yeah.
Calculate PLS predict. Can you see it?
Yes.
Calculate PLS predict. Then I click. Set the number of votes to be 10, number of repetitions to be 10. That's the threshold minimum values suggested in literature. Then you calculate. After that, Smart PLS will always give you an output without you having to suffer. Now, the first thing you want to consider, look at this rule. Please watch. Look at this rule. This. Oh, there's a rule, there's a rule, there's a rule, there's a rule here. No. No. Where's that? Let's predict. Yeah, this, please. This is the condition, very important condition. RMS is most suitable when the error distribution is highly non-symmetric, then we use MAAE. So now we want to look at the error distribution. Is it symmetric? If it is symmetric, we stick to RMSE. If it is not, we use MAE. Very important. So this is your criteria. So we go back to the PLS screen. Now, what you look for is you look for this under histogram. On the left-hand column, you can see graphical, this, that. Come to histograms. You can see PLS MV error histogram. MV means manifest variables. When you click for the endogenous variable, you can see. And we all know that normality is more of an eye gauge thing, but we can see that this histogram doesn't have a long tail anywhere, right? We can see that majority of the points are concentrated at the center. So we can reasonably assume that this is normally distributed, isn't it? Do we agree?
Yes.
We can reasonably
Yeah.
agree that this is. If we look at 2 also, this is for 1. We can reasonably say that most of the data points are concentrated at the middle as well. And if we look at 3, even though 3 is having a slightly skewed, but we can still say that majority are still at the center. It's more subjective opinion here, but since we have the first 2 to be highly concentrated at the center, then it's best to go with RMSE. Given that the error terms all appear to be symmetrically distributed. So, hello? Someone saying something? Okay. So what we now do is to open under final result. You open the MV prediction summary. Now, what you do is because we have chosen we have chosen RMSE values, you don't consider the MAE values. So this is our model, PLS, and then this is the benchmark model. So for all the variables we compare, our PLS value here should be less than this one. If it is less, if all of them are less, it means that our model has a very high predictive value. In this case, 1.239 is not great. It's not, okay, it's lower than what? 1.275, sorry, it's lower than 1.275. 1.414 is lower than 1.435. And 1.468 is lower than 1.491. Now, because they are lower, based on the criterion, even though I brushed over it quickly, if all indicators in the PLSM analysis have lower RMSE or MAE values compared to the naive LM benchmark, the model has high predictive power. But let's say out of the 3, we only have 2, then it means our model has a medium predictive power. Let's say out of the 3, only 1 is lower than the benchmark value. We can say our model has what? A low or very low predictive power. But if none of them has an RMSE value that is less than the LM benchmark value, it means that the model has no predictive value. And that is how you explain the power of your model. Any question?
Yes, please. Can
What's
you
your
please
question?
explain this, the summary, manifest variables prediction summary? What does this explain? PLS, SEM, RMS, E, and
Okay,
LMISM,
what is telling us is that,
values.
the essence of a regression model is to predict, isn't it? It's for you to
Yes.
be able to tell me that, take for instance, if I should go back to, okay, I'm going to close this. Oh, okay, from my model, I'm trying to say that competency, likability, and quality all predict customer loyalty, isn't it? And then
Yeah.
from the output we had in our previous structural validation analysis, we had something like 0.413 as the R square value, isn't it? Can you remember?
Yes.
So
yes.
the question is, how reliable is it that whenever I use competency level, likability, quality criteria to predict customer loyalty, how reliable is that model? How valid is that model? That about 41.3% of the time, the variation in customer loyalty is explained by these three exogenous variables. For me to actually assess that this model can reasonably explain this 41%, then I have to check the power of the model, which is what we call the PLS predict procedure. Do you get it now?
Okay. Yes.
That is why we do it. Any other question, please? Because we are coming to an end. In the absence of any question, thank you all for coming. Thank you for making the lecture interesting.
Doc,
We'll see you tomorrow.
Doc.
Yes.
Hello.
Yes, hello.
Please, it's really an interesting lesson, an eye opener for me. But we've seen some social statistical softwares like SPSS, which can also be used to do other analysis that are not like survey and those kind of things. I don't know if this software can also be used for such analysis. For example, you conduct your trial. I'm not a social student.
Okay.
So if I conduct my trial on the field, can I use this software to do other analysis apart from what you are teaching us to do?
You can use it to run confirmatory factor analysis, principal component analysis, but Smart PLS can you hear me?
Yes.
Hello? Smart PLS
yes, I can hear
is
you.
exclusively meant for structural equation modeling. So if you have, maybe you want to run something like panel data analysis, fixed effect model, random effect model, I think it would be more appropriate to use other designated software for that, like Stata, R, and the rest. So if your analysis is not related to structural equation modeling, then I think it would be best to use more reliable software in that regard.
All right.
Yeah.
Thank you very much.
You're welcome.
Okay,
Any other
thank
question,
you.
please?
Thank you, Doctor. Thank you, Phil, for giving us such an insightful time. And I also want to thank everyone who came for making today a very calm session. At least we didn't have lots of distractions, and this is the best we can always have. So I just shared a link. The video will be posted there in an hour. However, I would also share a link to the OAAD YouTube platform when their link is available. So if you need a video within an hour, you can check the link I just sent and you should have it. You can easily download it from that place using any of the YouTube download softwares. Okay, so once again, thank you and see you tomorrow. So we wrap up for the whole session. Happy learning and have a good evening.
Thank you, Femi. Thank you, Doc.
Thank you so much,
Thank you,
coordinator and
Dr.
tutor.
Fome.
Thank you,
Doctor,
Doc.
would you add our software? Yeah, PPT will be shared in the group right after the meeting. Our software, OAAD, will organize an R session probably the coming month. So Okay, so I think everyone has gotten the link now, and you can check there within an hour. It should be available for you to download.
Okay. Okay, Doc.
Okay, so
Thanks so
have a
much.
good
See you
evening.
tomorrow. Yeah.
So we end the session.